Condition for maximum current in case of a cell connected in parallel. So just like before, right, we have found that the condition to get a maximum current when the cells are connected in series is that the external resistance should be greater than the sum of the internal resistances. So similarly here we shall see what is the condition to get a maximum current I flowing through the external resistance R when these identical cells are connected in series. So when I say identical cells, mean each cells are having same EMF and internal resistance. The EMF is E, internal resistance is R. E, R, E, R. Right? So we connect them in this way, right, up to M times of rows. Right? Okay. Now what is the total EMF of the combination of cell? Total EMF. So because each cells is having, right, in one row, in one row the EMF is E, in the second row E, in the third row E, in the fourth row E. So when you join them in parallel, the total EMF we have seen right from before that the total EMF is actually the EMF or the potential difference between the 2 point A and B. So therefore the EMF of each cell, or the total EMF in this case, will be same, that is E. The total EMF between the 2 point A and B is E. What about total internal resistance? Because looking at the internal resistance, these resistance now are connected in parallel. So when you connect them in parallel, so we know from the combinations of resistors in parallel, the equation is 1 upon R. Okay, it is equals to 1 upon R plus 1 upon R plus dot 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 up to how many times? M times. That means M rows. So I can say this 1 upon R equivalent is equals to M times 1 upon R, or simply I will find out your R equivalent is equals to R upon M. So this is my equivalent resistance and this is my total EMF. Next, what is the total resistance of the circuit? The total resistance of the circuit, it is actually, because when you combine all the internal resistances, you'll get just one resistance, which is equals to this much. And now this internal resistance R equivalent, it is connected in series with capital R. So therefore total resistance of the circuit is R equivalent plus capital R, which means R upon M plus capital R, or R plus MR upon M. Okay. Next, what is the current that is passing through the external resistance R? This is equals to the total EMF upon total resistance of the circuit. Your total EMF is E. Your total resistance of the circuit is R plus M capital R upon small m, or I is ME upon R plus MR. So this is the equations of the electric current through the external resistance R. Now let me name this as equation 1. Okay, so just like in case of series, we draw two special cases. So similarly here we shall see two special cases. That is case number 1. If this MR is very small compared to or else I will write like this, sorry. Yeah, it's fine. If MR is very small compared to small r, then what happens to I? I is equals to ME upon R. So this is M times the current due to one cell. But if this MR is very large compared to R, then I is equals to, this small r can be neglected, you'll get ME upon MR, so this with this cancel, so E upon R only you will have, which means current due to one cell. So looking at these two equations, we see here in special case number 1 we will have a maximum current because it is equals to N times the current due to one cell. So this condition happens when this MR, that means when the external resistance of the circuit is very small compared to the internal resistance of the circuit. So when that is the case, then the current passing through capital R is maximum. Alright, so please remember this. In series combination, capital R should be greater than the sum of the internal resistances to get a maximum current. But in parallel combination, this this MR, when I say MR mean I can also say R should be less than R upon M. So this R upon M, I hope this is, you have seen, it is the equivalent internal resistance. So when this capital R, it is smaller than the sum of the internal resistances here, then the current in this case is said to be maximum. So please note down this point very carefully about the condition for the to get maximum current in series and parallel combinations of cell.